Hi guys, so we're back with the next video and today it's going to be about word embedding. So I'm Adi
And I'm Sudhi.
and so let's jump right into it. So what is word embedding, Sudhi? So when we want to represent a word as a vector, so we are embedding that word into a unique vector.
Yes.
That's called word embedding. Pretty simple. Why would we want to do this? So given a word, let's say an apple, when we cannot do any operations directly on the word, any mathematical operations directly on this word. So that's why when we represent it as a vector, so let's say 0.5, 3.2, and so on, we can now do mathematical operations on this vector. And not just with one word or one vector, we can have another one of the same shape and do some operations on them as well. So we can like add these or like divide or like concatenate, whatever we want to do when we have the words in a vector format. So Word2Vec is the most popular machine learning model which is unsupervised because all these operations are unsupervised. So is a very popular model developed by Google actually, which does this for us. Okay, so why don't we look into another practical example here? Okay, so these are all our words which we want to represent as a two-dimensional vector here. So with cuteness and size. Okay, so now the word kitten is represented as a vector of 95, 15. Okay. And similarly, all these vectors here, all these words. Sorry. So when we plot them in this 2D space, we can visually see which of these words are similar, which of these words are farther apart, and whatnot. So when these vectors, now we can do mathematical operations on them, find the similarity between two vectors. Okay, that's the most important one. We can find the distance. We can use cosine similarity here, and so we could find the distance. So let's say crocodile and elephant are really farther apart. We can find the Euclidean distance given these two vectors, and so we can see that these two are farther apart based on the size and the cuteness level here. We should keep that in mind. And at the same time, we can see that horse and dolphin are really close to each other when we consider size and cuteness. So this is a really good example. So we can do mathematical operations on these. We can like add two of them and see how we're getting it. What is the resultant vector we get, and find the similarity between the resultant vector and whichever one we already have. To wrap our heads around with this concept even more, one more really good example is representing the colors as vectors. Okay, the simple thing which we know how. Whoops.
That's fine.
Okay, sorry about that. My bad. So we know RGB, right? So RGB can be represented in this 255, 255, 255, in this 3D space, correct? So when we want to represent the word red, we can represent it as 255, 0, 0. So this is now the vector for representing the color red. And so we can keep going like this. So this is a three-dimensional vector to represent all these, correct? So this is also a good example when we look into it. So before we jump into the practical, this is really cool. The practical example today is going to be really cool. So how does, we're going to use Word2Vec here. And so how does it work? So it takes in a word and it converts it to a vector. And we use this vector as the input to the whole machine learning model. And so that gives us an output, and that output is again mapped to a natural language word, and that is the answer which we get. Okay, based on the distance. Really simple.
Yes.
So why don't we see an example?
All right.
Sudeep?
Sure. Let's look into an example. So Jensen provides a model basically for a keyed vector. So basically for a word to vec model. So here I'm considering a Google News vector negative 300 binary file. I'll leave a link below in the description to download the file. It's actually a huge file of size 1.78 gigs when it is compressed, but when it's uncompressed it's a 3.64 gigabytes of data. That's because there are about 3
Mil.
so of size 3 million by 300. So each vector is each vector is of size 300. And let us look at some of the examples that I have already coded. If you want to find out what are the most similar words with respect to man, and what are the most similar words which are with respect to queen, but not with respect to kings and king. So that's why we have a negative of kings and king, and we are only interested in top 5 results of all both of these most similar thing. So when we print them, you can see that man the word man has closeness to woman, boy, teenager, girl. So, and these are the distance between the two vectors. That is the Euclidean distance between man and a woman, man and a boy, man and a teenager. And this is arranged in a descending order. So the first one is the closest one to that word. Similarly, for the word queen, which negates the word kings and king, has a very low similarity score. That's because it's eliminating most of the words in and around kings and queen, because king and queen are kind of like related words with respect to the vector itself.
Yeah. So you can imagine this as from the previous example. So the word man is in this 300 dimension space, and so we're finding the Euclidean distance from that word man to all the words near it, and we're displaying the top 5 closest to that.
So similarly, we can also find with respect to names. So here I'm considering Tolkien. As you all know, it's the Lord of the Rings, the writer of Lord of the Rings, and all the similar words with respect to Tolkien are J.R.R. Tolkien, his name, and you can also see the Lord of the Rings is here with the distance. So this is one of the good example that you can look into. But previously, when Adi was explaining representing words in the form of vector and putting it back to the machine learning model, this actually takes care of everything internally. But when you want to look into the words in depth as a vector, we can also check what the vector representation of each word is. So for the word red, this is the vector representation of 1 by 300. That means this word has 300 size vector. And we can also add 2 vectors, as he said. We can do mathematical operations on the words and check what are the similar words with respect to those operations. So when we add red and green, we have a sum of 2 vectors, and this is what we get. This can be fed into the machine learning algorithm, and that gives us the distance to the closest word in the cluster. And similarly, we can do it for a food like pizza, and see we have pizza, Domino's pizza sandwich and stuff. But the previous example here with red and green, when we feed it into the most similar, the Jensen model, we as you all know that 255 plus 255 in a RGB model is yellow, and the closest distance here we have is yellow for the words red and green. You can try this with a lot of examples, like anything.
You can try it with your name and see which are closer to yours and stuff. It's really cool. So you should play around with this. Obviously, we'll include all the code examples and references in the description. And so, yeah. And
Alright.
we're done for today. See you.
See you. Bye bye. Thank you.